In this lesson, we're going to look at graphing systems of inequalities, specifically when it comes to parallel lines. By the end of this lesson, you should be able to identify the different types of solutions that you get when graphing systems of inequalities in parallel lines. Remember that a solution to a system of inequalities is a region where two or more of the inequalities overlap. It's not just a point. Solutions are going to be like compound and inequalities. It's where, again, where they overlap, where those sections meet. There are special cases when the boundary line is parallel. The solutions may be between the lines. The solutions could also be above or below the lines. And so just kind of be aware of that. There's going to be cases where there's also no solution, and that's where there's no overlapping. Okay, so let's look at example number 1. It asks for which quadrant of the graph is the solution to the systems in. So if we look at this first one, looking at the red, it says everything greater than or equal to 1. So that would be everything that's above 1. And then for my blue line, that's everything that is less than, well, that's x is less than 2y. So in order to solve this one, I'm going to have to get it into slope-intercept form first. So let me divide everything by 2. That's going to give me y is greater than 1/2 x. So y is greater than 1/2 x. I'm going to rewrite it. That's helpful for me because now I know that I'm looking at everything that's greater than or everything that's above. And so my solution, remember, is where they overlap. So my solution is going to be in 2 quadrants. It's going to be in quadrant 2 and it's going to be in quadrant 1. Okay, so if I'm graphing this one, again, notice that I have parallel lines here because their slopes are the same. Y-intercepts are different. So I'm looking at this first one. It starts at -3. Slope of 2, so go up 2, right 1. Down 2 and back 1. A dashed line here because it is not equal to, it's just less than. And this one has y is less than 2x minus 3. So my solution for this is going to be everything that is less than below. Remember that when my equations are in slope-intercept form, I can look at the inequality and that will tell me which side to shade. But I can only do that when it's in slope-intercept form. My next one says start at 2. So for my blue, remember that it's parallel, so it also has a slope of 2. Also dashed. And this is greater than, so my solution here would be everything that is above my blue line. And so what we see here is that there is no overlap. And so because there's no overlap, this would be no solution. So in parallel lines, when graphing we have parallel lines and there's no overlap, then that would mean that there's no solution. Let's look at the next one. So if y is greater than x minus 3, so again we have parallel lines. This says start at -3, has a slope of 1. Dashed line here. So again, we're not including it because it's just greater than. This is greater than, so I want everything that's above. So everything that's above, there we go. And then I have y is less than or equal to x plus 1. So it says start at 1. This has a slope of 1. Again, should be parallel. I'll have a solid line here. and this is everything that is less than x minus 1. So when I'm doing this one, it's going to be everything that's below. And so my solution here is where they overlap. So my solution is going to be everything that is in between the parallel lines. So again, shade, and from the shading you'll be able to tell where the solution's at. Looking here, I have y is less than negative 3x minus 2. So I start at y equals negative 2, or I start at negative 2. This has a slope of negative 3x, so it says go down 3 and right 1, or go up 3 and left 1. A solid line. So I'm including. This is going to be everything that's underneath. So underneath, because it's less than, is here. It's below the line. My next one is y is less than negative 3x plus 4, so this is start at positive 4. Again, less than, that means go down 3, right, or negative 3, go down 3, and right 3, or down 3 and right 1, down 3, right 1, or up 3, and left 1. Again, solid line, because we're including. And it's everything that is less than. So my solution for this one, again, is where they overlap. They overlap here. So again, my solution is going to be everywhere that they overlap. So all of the red solution, but we're excluding some of the blue. So this is the solutions below one of the lines. If we look at a word problem here, we have Steve is going shopping for some shirts. He needs to buy, he's going to buy dress shirts for $22, t-shirts for $15. He can spend up to $100, but wants to spend at least $90, and he needs to buy at least one dress shirt. So we're going to write a couple of inequalities here. The first inequality is going to consist of the number of dress shirts, so 22 for each dress shirt, 15 for each t-shirt. He can spend up to $100, so he can spend less than or equal to 100, so he can't spend more than 100. But we also know that he wants to spend more, or at least 90. So 22x plus 15y is greater than or equal to 90. So there's two of our inequalities. And he needs to buy at least one dress shirt. So we need x to be at least greater than or equal to 1. Okay, so we're going to, in our graph, we're going to make the x be the dress shirts. So our x-axis will be dress shirts. The y-axis will be our t-shirts. I'm going to go ahead and graph x is greater than or equal to 1. That's going to be a vertical line. The number of dress shirts needs to be greater than or equal to 1. So that would be everything that is to the right. Okay, we're going to have to change both of these other equations into slope-intercept form. So I'm going to change this first one, subtract 22x, that's going to be 15y is equal to negative 22x is less than or equal to 22x, negative 22x plus 100, divide by 15. So I get y is less than or equal to about negative 1.5 plus 6 and 6.6. So I can't necessarily graph 6.6 on here. It'd be somewhere up here. But if I go down 1, that would be 5. So it'd be about 5. And then over 1. And if I continue to go down, and over 1. Let me change the color here. So again, my graph's not going to be exact, and that's okay. Remember that when we're graphing, we don't always have to be super exact. We want to be as close. We want to be close. But when we're dealing with decimals, sometimes decimals are not going to be exact. So for this first one, it had to be y is less than or equal to that. So we want everything that is below. So no, right now I'm looking at my solution to be in where the overlap is for the blue and the red. I still need to solve this last equation. And so I need to change this. So 22x plus 15y is less than or equal to 90. 15y is greater than or equal to negative 22x plus 90. Y is greater than or equal to negative, again, 22 divided by 15 is about negative 1.5. 90 divided by 15 is 6. So again, I don't have 6 on there, but if I go down 1.5 from 6, that's going to put me here and going over 1. And if I go down 1.5, I'm going to point it there, and if I go down 1, 5, and go over 1, again, it won't be exact. That's okay. Because the point here is to make sure that we get a region. This is everything that's above. So we have this teeny tiny sliver of space right here. And so our possible solutions would be anything that is in the green. So you could get 4 dress shirts and possibly 1 t-shirt. Again, you'd want to check your solutions here. You could get 1 dress shirt and maybe 5 t-shirts, and 5 t-shirts. So we don't have a whole lot of options here, but those are 2 options that he could potentially have. Okay, before watching the next video, please consider the following statement. The possible solutions for parallel lines are,